Right, welcome everyone. Thanks for coming along to this webinar. I hope you enjoyed Fernando's talk earlier. I'm going to be talking about another feature that we'll be releasing into Starboard soon, and that is detecting anomalous vessel movements using the AIS data that we're ingesting. So you've probably seen something, and Fernando showed something similar earlier, but Starboard isn't about just displaying AIS points or the latest AIS point. We're really about taking that information and turning it into usable, actionable insights. So with Starboard, you don't just get a track, you get all of this additional information. So you'll get things like encounters, fishing, loitering alerts, entering and exiting areas. And as Fernando just discussed, this whole network analysis feature that we're introducing. And the other thing that we've been working on is this anomalous movements feature. So that's really about detecting when a vessel does something unusual in the sea while it's traveling, and how can we bring that to our users' attention. So this is the view you might get when you log into Starboard. This is looking at 1 day of data in the Indian Ocean. And it's a lot of data, right? There's something like 12,000 vessels showing on the screen. And the real question is how can we serve up the information, and how can we show you the information that is useful to you, and so that you don't miss what might be happening along these routes or on this track or in this picture, that unless you're looking for it, you don't know that it's there. So as I said, we've been working on this anomalous movement detector. And basically, when we apply it, we go from this 12,000 vessels down to 500, which is a much more kind of manageable number of vessels to deal with if you were an analyst looking at the behavior of vessels in this area and trying to work out which ones might be of more interest to you or your organization. And this talk's just going to go through how we do that. So we'll talk about the algorithm and the approach we're taking and why we do that, and then show some examples. And yeah, and there'll be time for some question and answers later on at the end of the talk. So how are we doing this? What's the algorithm we're using? We about 2 years ago, we started looking at this in more detail, and we looked at a few different algorithms and saw what kind of research was out there. And we came across this one here, which is GeoTrackNet. And that it was sort of, at the time, and probably still is, kind of the most state-of-the-art algorithm. It's very flexible. It was developed at a university in France, one of the Écoles Polytechniques, and it was open sourced, which we quite like because it means we're not trying to hide anything from our users. Our users can go, they can read the paper, they can see how it works. That gives a bit more confidence in the results that we are providing to you. So we started looking at this, and then a few months after that, we won a tender to work with the Australian Geospatial Intelligence Agency and a company called Frontier SI, and they wanted to kind of dig into this anomaly detection problem with AIS data, and they sent out a call for proposals, and we submitted one, and we were awarded it. And for us, it wasn't really just about developing the algorithm as such, but it was more about learning what analysts are looking for when they look at anomalous movements. and then deciding if this algorithm can answer those questions. And so we spent about 5 or 6 months working with AGO on this project, talking to their analysts, iterating through the model, developing it. And at the end, I think we were quite confident that it does provide information of value with some caveats, like and we'll get to those later on, but it is, we decided, a useful tool, and we wanted to pursue getting it into Starboard. So the model is called GeoTrackNet. And you know, what is GeoTrackNet? The technical name for it is a variational recurrent neural network architecture combined with an a contrario process, which is a bit of a mouthful, but we can break that down and kind of explain some of the terms that are being used here. So the key one is the recurrent neural network, and this is a machine learning architecture that is used quite frequently for time series or sequence data. So the one you probably come across the most would be something like a Siri or Alexa app would be based upon a recurrent neural network. So that identifying a time series, which was, you know, speaking into your phone. The variational part is a method of incorporating probabilities. And this is, we thought, quite key to the developing this anomaly model, because vessel movements are fairly noisy. There is a lot of variation within what would be considered normal vessel movements. And so by having this probability distribution part of the model, it allows it to capture that variation more accurately and more completely. So you're not raising false alarms as frequently as you otherwise might. And the last part is this a contrario process. And this is essentially just evaluating your point against a reference distribution. And if it's below a threshold, then you would consider it an anomaly. And likewise, if it's above a threshold, it would be considered normal. So the key kind of point of the GeoTrackNet algorithm is that it's learning to represent normal behavior. So it's learning what is normal from a historical perspective. And then that allows us to flag unusual behavior based upon the historical normal data. So we had to train it. It doesn't come pre-trained. So you have to collect a data set and run it through the model. So we processed something like 1.7 million 24-hour vessel tracks, and this is globally. So we run the model globally. We exclude some activity like fishing and port visits and near shore activity, just because the movements associated with those kinds of activities looks anomalous, but it isn't anomalous because fishing is something that a fishing vessel will do, and likewise visiting a port is something that most vessels will do. So we didn't want to flag that kind of behavior, and we didn't want to include it in the data set because then it would reduce our ability to spot anomalous movements that look similar but are actually anomalous when we're applying the model. And then you run the data through the model and it kind of learns the best parameters. And then you've got a fully trained model, which you can then apply new data to going forward in the app. So basically, this is how it works. For each vessel point, we take latitude, longitude, speed and course information that we receive via AIS. We put it in the GeoTrackNet model. And I mentioned before that it uses this probability, it has a probabilistic component to it. And so what it's outputting is the probability of that particular movement based upon all the historical data that has gone into the training set, into the model to build the model. We then take that probability and compare it with a localized threshold. And so if it's below the threshold, it's anomalous. If it's above the threshold, then it's normal. And we're using a localized threshold because vessel behavior is different around the globe. So what's normal in the straits between England and France, that sort of behavior would be different to what is normal in the Pacific Ocean. So you can't just have one threshold, you need like a localized threshold, which is what we're doing in this model. So we've got a bit of a quick kind of conceptual example of how it works. And what you're looking at here is just a normal distribution bell curve plot. And this would be our reference distribution. So this is the distribution of the points in a localized area, which is about a 500-kilometer radius, based upon the output of the model from the training data. So that we've run the data through the model, it's output the probabilities, we've collected these in a localized 500-kilometer radius area, and then this is imagine this is what the distribution looks like. So then we define a threshold, and that's illustrated by the dashed line here. So anything to the left or below this would be anomalous, anything to the right or above would be considered normal behavior. And this is how it works with the vessel points. So if you imagine we've got two vessels starting off at a fairly similar location, so vessel A and vessel B, what we're doing is we're passing the latitude, longitude, speed, and course into GeoTrackNet, and it's outputting these probabilities. So probability of the point of vessel A, and the probability of the point of vessel B, which is the dot and the arrow. And then so as the vessels proceed along their track, you can see that they'll be outputting probabilities. Generally, if they're close together, the probabilities should be pretty similar. There might be a few differences because this is a probabilistic model, but generally they should be similar. And what happens is when one of the vessels, in this case vessel B, starts to vary its trajectory and veer off the straight path that it was carrying on, then its probability of that point falls below the threshold and it gets labeled as anomalous. And this kind of continues. If you imagine this vessel is doing in like a circle, all these points that are sort of unusual or unexpected will get flagged as anomalous. And eventually, when it gets back to its original trajectory, the points then become normal again. And that kind of continues on. So we're running this algorithm, like I said, on a global data set. We run it every 3 hours using 24 hours worth of data. So you get this kind of near real-time picture of vessels behaving unusually in the ocean. And then that anomalous movement is stored and it's logged against the vessel's history. So you can see it under a list of events associated with that vessel as well. Excuse me. So with any model, there's going to be benefits and challenges of it. One of the large benefits of GeoTrackNet is that it's unsupervised. And that means that we haven't provided it labeled examples of anomalous movement for it to learn. Like I said, what it's learning is what is normal. And then we're taking advantage of that to flag what is unnormal. This is good in the sense that labeling, things like anomalous tracks is a very time-consuming process. It requires fairly expert knowledge to do that. And it would be fairly specific to individual use cases. So what's anomalous in a shipping context would be different to what's anomalous in, say, like a fishing or yachting kind of context. So you could develop a labeled training set and attempt to build a model to do that. What this does is avoids that and because of that, it is a lot, it's able to capture a lot more behavior. It's a lot more general than a very specific targeted model would be. That comes with a downside, and that it is very general. So we're not attempting to classify the anomalies by their type. So we're not attempting to classify, say this is a movement anomaly. This vessel did a circle, and that's something that we're looking for in particular. We're just labeling anything that is unusual as an anomaly, and it's kind of up to the analysts and their expert knowledge to understand if that anomaly is of interest to them. The good thing though is that Starboard, because you have all this kind of extra information in Starboard, you can readily see that if a vessel that is flagged as anomalous has done just a course change, or if it's maybe crossed across a shipping lane instead of following a shipping lane. So having that extra context in Starboard allows you to determine whether or not an anomaly is worth following up or not. Cool. So we've got a few examples of some anomalous behavior in the app. Sorry, let me just jump to this one here. So this is an example of just a view in the Pacific. So we're sort of between Niue and the Cook Islands here. And we've got 179 vessels on screen that match the current filter. So if we want to just reduce that down to the anomalous vessels, what we do is we go to add a filter, look at vessel activity, and then just click on this anomalous movement checkbox. Done, and then that reduces what we're looking at to just the anomalous ones. If we zoom in on this particular one here, which is the Imua, from this view, it looks like it is just traveling along, going at a straight course between Niue and the Cook Islands. If we zoom in closer, like this, we can see that it's actually done a loop. So it's exited the Niue EEZ, done a loop in the middle between the two EEZs, and then gone on into the Cook Islands EEZ. And this is quite a cool example because, I mean, we see a lot of these loops, and we're reasonably confident it's just something like a man overboard kind of drill or something like that. So not accusing them of doing anything illegal, but it is an idea of how that you wouldn't necessarily see this unless the anomaly detection had brought it to your attention. Yeah. So if we look at another example, this is in the Tasman Sea. So we flagged these couple of vessels, these 3 vessels, as being anomalous movements. And that's kind of because they were all going from sort of Sydney-ish area down to Invercargill, but well, these 2 were, and this one was going across to Wellington. But they took these kind of circuitous routes to get there. I mean, normally you just go the direct route. And if you just look at it, you're kind of like, oh, why did they do that? That looks a bit strange. But what we can do with Starboard is add on the wave height base map. And you can see what they're actually doing is avoiding this very high wave height in the middle of the Tasman, which is 7-8 meter swells. So having that additional context from the environmental layers demonstrates that it wasn't a suspicious anomaly, it's just a vessel attempting to avoid some weather in the Tasman Sea. This is quite an interesting example. We're here in the Indian Ocean, and there are these two vessels that have been flagged as anomalous. And basically what we've got is the grey palm here is, zoom a bit, is just sort of hanging out in the ocean. This is the Indian EEZ over here, I think. And the grey palm is just kind of hanging out, going back and forth. And the Dionysus comes in, and it changes course and slows down and then carries on its way. And this is kind of interesting because it's entirely possible that there was an encounter here, that the encounter algorithm just hasn't flagged because it was such a fleeting, quick encounter. Maybe it wasn't vessel to vessel, maybe it was inflatable to inflatable to vessel, something like that, which we can't pick up with the encounters algorithm, but having this anomaly detection flag it still brings it to analysts' attention in the app. And just the last example we've got here is off the coast of the US. This is the Pacific Northwest, so we've got Oregon and Seattle up here. And this is just illustrating you've got quite a lot of vessel traffic traveling in fairly straight lines. And there's one vessel in particular which gets flagged by the anomaly detection is this bold horizon vessel, which is a survey vessel. So even though it's kind of traveling along similar lines to the rest of the vessels in the area, it is doing these sort of funny slowdown, stops, turns, and then kind of carrying on. So even though it has components which are similar to the other vessels in the area, it is behaving differently enough, and the anomaly detection has picked that up and brought it to our attention. Yeah, so those are the examples we've got. I just pop back here. Yeah, so that's just a kind of overview of how we've implemented the GeoTrackNet anomaly detection in Starboard. So it allows us to flag anomalous vessel movements in near real time globally. Having the rest of the information in Starboard allows you to see the context around the anomalous movements, which is very useful, very important. And it also integrates with all the other Starboard features. So things like alerting, tagging, downloading will work with the anomalies as well. And it's coming soon to all our users. So we are hoping to get into beta soonish, and then eventually release to all our customers. So thank you very much for joining us, and yeah, feel free to ask any questions.
Awesome. Yeah, thanks for that, Joe. So we've got some questions coming in at the moment. So the first one is, could you use this approach to predict expected or normal future behavior if we know what normal looks like?
Yes. Yeah, you should be able to. So yeah, it would predict the way it works is you get a distribution, and you can sample from that distribution kind of like the next step ahead, and then you could sample from them, put that into the model and move ahead. So yeah, you could predict future positions over like a short time period, I think. If you went too long, it would start to diverge.
Awesome, thank you. One of the other questions we've had come in is around the event feeds on an API. So I know you were saying that all of these anomalous alerts are logged against all the vessels that we're tracking globally as a key event. So could you actually get that via an API into your own systems as well? Yeah, this data will be available through our API.
as other events are as well. So encounters, fishing, that sort of thing.
Yeah. And if you were to take a different set of data and put it into the model, could you use something that wasn't necessarily AIS to put into the model as well?
Maybe. It's possible that it would work with something like VMS. It uses a 10-minute sampling of vessel positions to do the model, to do the predictions and the training, that sort of thing. So VMS might be a suitable data source for that.
Yeah, cool. I had a question. It's about trying to find a specific vessel in the WCPFC area, ideally a persona, just to look at as an example of its patterns. So I'm just going to ask if there is a specific vessel. One thing I would say to Joe's point earlier is that we exclude the actual fishing activity and any of those near port, near shore movements from the model, so it doesn't kind of skew the overall movements within that localized threshold area. But I'll just ask now for if there's a specific vessel. Oh, so that's that one. What else do we have here? There's a question here which I think you've kind of answered. So when you found that that surveying vessel, and I guess this is maybe relevant to the other example you showed in the Indian Ocean as well, once you've got an example of something like that survey vessel where you can see those patterns and movements and behaviours, is there a way of then sort of use that to find other vessels as well, so other vessels that are looking at the seafloor on the basis of one pattern of movement, or is it a case of vessel by vessel, case by case? What is an anomaly as in terms of where it is?
Yeah, no is the answer to that. Not at this point. That would require an additional model on top of this output, whereby you'd classify the different anomalies into types if you knew what type of anomaly you were looking for. So yeah, so we don't have that. This model doesn't have that capability, but it is something that that maybe we can look at in the future as a good feature.
Yeah, cool. And sorry, we had another question come in there, which I can answer. So in terms of how we determine an anomalous movement of vessels with color changes, Joe, could you just jump back to the movement of the dots? We can kind of talk through, took that again. So we'll just quickly jump to that. In the meantime, any other questions, even within the platform that you want us to have a look at, please do put them into the chat and we'll answer those. We can go back into the live platform as well and have a look at any live examples if you're interested in that too. So just actually within the slides, could you go back to the...
Oh, sorry.
Yep. So the dots, so when you're showing the distribution curve, yeah, exactly that one there. Cool. So if you take that back to the start of the movement. So let's go back about four slides.
Sorry.
Yeah, awesome. So as Joe's kind of running through that, as he mentioned, you've got those two vessels traveling on the same trajectory, and that distribution curve of that little graph to the right of the dots, you can see what is normal in that area. So within a 500-kilometer radius of the vessel that you're looking at, what does a normal vessel movement look like? And then as soon as vessel B starts to deviate and do the loop, you'll see that that track suddenly jumped outside of the norm. So that dashed line is the sort of threshold of normal. As soon as it did that loop, it suddenly sat outside of that and was flagged in yellow. So that would appear within Starboard as that yellow line, that yellow movement, and logged against that vessel's history as a key event or anomalous movement detected. And so you would have that for all vessels that we're tracking globally on AIS. And it's the great thing about it is it's entirely relevant on where that vessel is. So we're not using a blanket model to cover everything globally. We're looking at within 500 kilometers of the vessel that you're looking at. What are the other patterns of behavior of vessels in the area, and does what this vessel is doing match with what they're doing? Also, another question around the thresholds. Can you just talk more, Joe, around the thresholds? What actually are the factors that the threshold is based upon?
Yeah, so it's a bit of a dirty secret of most machine learning algorithms is that they involve a threshold. So it might look a lot like magic, but at some point in there, I assure you, there's someone has set a threshold above which some type of activity is classified as something, and below it's classified as something else. So the threshold in particular, that this one we're looking at here, is it's basically a way of separating normal probabilities that come out of the model versus the abnormal, the anomalous probabilities. And that is it's developed from the training data set. So when we run the model, run the training data set through the model, we take those output probabilities, we group them locally, and then from that we determine a threshold. So the actual threshold is the lowest 10% of all the points in the of all the probabilities in the distribution. And yeah, and that is like a choice that we make. So depending on how you set that threshold, you can get more or less anomalies. And it's a bit of a trade-off between the kind of the false positives and the false negatives. We've kind of erred on the side of showing more anomalies and letting the analysts like filter it out themselves. But it's still something we're kind of working on and tuning a bit to get the best result.
Cool. I've got a couple of questions around sort of related to AIS data gaps and how they sort of fit with how the anomalous movement model works. So there's a question here to say, would the model show up if a vessel's AIS pings in one location and then jumps thousands of kilometers to another area, possibly indicating a sharing of MIMSI numbers? So how do we handle those crazy sort of data gaps? That doesn't really sit in the anomaly side of things. I guess that becomes more of the ghost vessel spoofing mechanic, or how would the anomalous movement model work in that situation?
Yeah, that's a good question. So the anomaly detection might not ever see that. When we ingest data into the platform, we check to see if for a given MMSI, the next point is actually feasible, like it could actually feasibly get to that point, given the time difference. If it doesn't, if it couldn't get to that point feasibly, then it gets split into a new vessel. And so the way the anomaly detection works is that it only runs on what we think is individual vessels. So it probably we wouldn't actually get that data into the model, unfortunately, because that would be a good way to, I imagine if it did, it would show up quite obviously.
Yeah, nice one, thank you. I also had some follow-up to the question around the vessel, the persona vessel, a particular vessel to have a look at, which I've found, and I'm just going to share my screen with you.
Sure.
Yeah, that's fine. Check and share here. And actually, interesting thing about this vessel, to the attendee that asked that, it's got no anonymous alerts, no anomaly alerts, but a ton of AIS data gaps and missing and missing activity and some strange patterns of behavior. So it's definitely got some strange movements, but we haven't picked it up in the anomalous detection model. And I think a lot of that is because, as you can see here, there's it's sort of when we've rolled it out into the live data set. So it's yeah, there are definitely probably some questions you want to be following up on that vessel, but yeah, I'd say personally probably related to those significant AIS data gaps that you can see here in its track history. And this is looking at from the 30th of April 21 through to 22. So which is a good point actually. So Joe, when we do release the anomaly detection model, how far back will it go in terms of being able to look at this behavior within the database of vessels? How far back in time can we go to look for anomalies?
We haven't kind of finalized that yet. We could probably, it would have to depend on if there's a need for it and the if our users are asking us to develop to run it on historical data. I think initially it would be just fairly recent, but we could go back in time if needed.
Nice one, thank you. I don't know if you wanted to go back to sharing your screen. So we've also got another question that's popped up. And thank you for all these questions. Appreciate it. Can the model take into account the weather data as part of the algorithm? Okay, that's a great question. So we showed the example before of in the live platform, 2 vessels that had been flagged as taking an anomalous voyage or anomalous movement. And then when you overlaid that weather data, it kind of explained it or validated the behavior. But will the model eventually take into things like localized weather into account as well?
Yeah, at the moment it doesn't. We don't include those as kind of external factors, but in the future, yeah, that would be something we'd be keen to explore is what weather events we can include to kind of better classify tracks as anomalous.
I had a question as well, actually, because I've seen it in the demo platform a few times. But why is sometimes there's a straight track that comes up with an anomaly? What's causing that?
Yeah, so there's a couple of things that it could be. It could be on a route which is somewhat unusual. So instead of following along a shipping track with the rest of the ships, it could be cutting across one or have deviated kind of within a couple of degrees or more from the rest of the vessels on that track or the track that those vessels would normally take. The other thing is that it could be it could be a false alarm. I mean, that's definitely possible with this type of model, as you might get a flagged anomaly that isn't really anomalous, but the model, because we're using a threshold, the model has just kind of classified it below the threshold, and as such, it's been flagged as an anomaly.
I've got a follow-up question as well. Currently, Global Fishing Watch, and you have to excuse if you can hear building in the background at my end. Currently, Global Fishing Watch has integrated VMS data input into their system. Is Starboard looking into this option to partner with countries for VMS data integration? Which is a great question, and thank you for that. And I can confirm that, yes, that is something that we're looking to do. We're absolutely looking for pilot partners, and we've sort of started our first steps into integrating some of those boxes into Starboard in a sort of a test phase at the moment. So if that is something of interest for sort of future work, yeah, we'd love to open up that discussion as well, in particular. So I'll just put a last call out for any other questions, or Joe, if there was anything else that you want to talk to. I appreciate we're sort of coming towards the end of our time. Were there any other questions that people had, if you want to put them into the chat before we sort of wrap things up? While I'm asking for that, or while we're waiting for that, I'll say as well, we are going to start a beta testing phase as well. So yeah, we'll start an initial rollout with a view to getting this into the platform very soon. So the 2 big releases that we've talked about today, network analysis and an anomaly detection model, will be coming into the Starboard platform for all users imminently. Cool. It looks like we have finished in terms of questions. So yes, I'd just like to take this chance to say thanks to Joe for talking us through anomaly detection, and thank you to all of you for attending and sticking with us. And just as someone starts to fire up a power drill in the background, sorry about that. Yeah, thank you very much. We will have more of these webinars, so do keep posted. We'd love your feedback on this as well. And any follow-up questions or additional information that you'd like from us, or even if you want to have a follow-up demo or talk about things in more detail, then please do get in touch. Our details are on the screen, and we can talk to all things Starboard further and some of your specific use cases. But thank you very much for joining us.